When working with music notation digitally, it is represented in a few common ways. One of the most common is music XML. Looking at the example, it can be hard to make sense of what is being represented within the notation. After converting it into standard musical notation, it becomes much more apparent what is being represented. This is a problem given to our group, Music Score Visualization. Our team consists of 4 members, Victor Marquez, Paul Koos, Alexander Prestwich, and Chenea, working under the direct guidance of our project partner, Dr. Patrick Donnelly of the Soundbender Lab.
The problem that our project set out to solve is to provide a solution to the lack of open source and inexpensive music score software. While there are existing music score software, they tend to be proprietary and expensive. To name a few, Sibelius, Finale, and MuseScore, some of the more popular music score software, can all have costs ranging upwards of $100. In the case of Sibelius and MuseScore, this cost would be subscription-based, so you may even be paying this price yearly. Of course, there exists other music score software out there. However, these 3 examples are some of the more popular ones and can paint a good picture of just how expensive music score software can be. As for the project requirements that our group had to meet, there were a couple of different categories. First and foremost, development-wise, we would have to create comprehensive suites of unit tests for code validation. Additionally, we would have to conform to the latest Python style guide and provide professional documentation. As for file input, the main requirement for this project was that it would be able to accept files of the music XML format. However, as a bit of a stretch goal, this project also aimed to be able to accept MIDI and XML file formats. For the application window, a requirement was that it would represent a musical score passed in as input while conforming to musical expectations. Additionally, the application window itself would include window scrolling and zooming as user input. In particular, the window scrolling functionality should be able to take the location of the cursor as input from the user. As the cursor approaches the edges of the window should scroll in that respective direction. These 2 bits of user functionality are incredibly useful when navigating the application window, especially when taking into consideration the final requirement, no pagination. This final requirement would mean that instead of a score being represented across multiple pages, the entire score will live in the application window with no page breaks. This would also mean that instead of a staff being represented across multiple lines, it would be represented through one continuous horizontal line. As for the stretch goals of this project, one of them was to be able to save the score represented in the application window as a PDF file. Another was to implement the user functionality, allowing them to click anywhere on the screen and collect a slice of information based on what they clicked on. For example, if the user were to click on an individual note, it might return the pitch of the note and any accidentals attached to that note.
The result of the project looks as is shown on screen. It is a standard musical notation view of the data stored within a music XML file. The amount of music notation elements is endless, so for this first iteration of the module, we focus on the most fundamental notation elements. These include, but are not limited to, the following elements that we have implemented. These are clef, time signatures, notes, ledger lines, slurs and ties, beam notes, accidentals, and bar lines. In addition, there are a few UI features within the window that we have implemented. These include scrolling, score information, window resizing, and score slicing. All these features will be shown within the demo portion of the video.
And now for a demonstration of the application. First thing I want to point out is that every item on the screen is individually drawn and positioned. And so, for example, each clef, each time signature, each note, each line, each accidental, all of those are individually positioned on the screen. So that was where a lot of the project went, to figure out exactly where things go. With this, some of the functions that we have as far as our interface is we have scrolling. You can scroll with both your mouse And so you'll see there's two different speeds of scrolling. There's slow, and then there's fast. It stops near the middle of the screen. You can also scroll in multiple directions at once. Another option is that you can scroll using keyboard shortcuts. This is nice because it allows for a little bit more precise movement. Another UI function that we've added is an information graph, which is in the bottom corner. It will show the title, the composer, the rights, everything there. You can click on it to display and then click on it to hide. And one of the main features is that you can scroll every part, which are these separate clefs and separate lines. Every part will scroll in unlimited amount. So as we're moving through, this is the entire score, Mozart Trio. You'll see that the spacing for each individual note is correct. And it goes until the end of the score. This is nice because you do not have to flip pages. You can just see everything on one screen. Some other things to point out is there's different types of notes. So you'll notice that there are quarter notes. This is an eighth note, but there's a filled in note. There's a hollow note. This is a half note. There's dotted notes, which adds half of the size of the note back to it. There's also rests. The rests themselves are one thing that we do need to work on a little bit further. These are not the correct size of rest for the amount of space that they take up. A couple other things that we need to work on and are going to be left for future teams to work on is we do not have bounding at this point. What that means is that as you scroll to the left, you'll see that the background just stops. This is something that will be given to the project partner and needs to be worked on as well. You'll notice it at the bottom as well. But overall, this is a live demonstration of the application.
All right, so this concludes our team's portion of work on the music score visualization project for the Music AI package. Once we hand off the project, a future group will take over and work on the features that still need to be implemented. These features include chords, keyboard parts, which is a big one, lyrics, percussive notes for instruments like drums, tempo markings and beats per minute, and note accents. Some of these features require work on the core data structure of the Music AI package before they are able to be represented visually. And this concludes the presentation of the Music Score Visualization project. Thank you for listening.